Alright, again simplifying algebraic expressions, but now we're going to work with, we've been doing addition or positive numbers, now we're going to do subtraction or negative numbers. Alright, and I'm always interchanging these numbers, the expressions subtraction, negative, and addition and positive, because you're going to be learning about integers, and integers just mean positive or negative numbers. We worked with the number line before, so you know that we do have negative numbers, and we'll see how to work with these. Now let's look at this first expression here. X minus x. Well, what does that mean? Don't forget, first off, is x or the variable ever alone? No, he's always got his buddy number 1. So there's number 1. Does that make more sense? 1x minus 1x? Well, let's see. That could be thought of as 1 minus 1. What's 1 minus 1? If you have one ball here and you take away one ball, how many balls do you have left? 0 balls. Alright, so here, if we have 1x and we're taking away 1x, how many x's do we have left? We have 0 x's left. Alright, so if you have x minus x, even if without that thinking about the 1 in front, if you have an x, if I'm taking away that x, how many x's do I have? 0. I have no x's left. Alright, the same thing if I had another coefficient in front of this. If I had 2y minus 2y, I have a positive, I could put a positive symbol here, positive minus another positive, or no, it would be a positive minus, or positive, what we say is add its opposite, like this. You could look at it that way. So if I have a 2y plus a negative 2y, that's just canceling each other out. That's what we did earlier with our variable worksheet. This just cancels each other out because they're the opposite. So if I have a positive 2 and then I have a negative 2, they cancel each other out to 0. Same with this. I canceled my term out. A positive 2y plus a negative 2y cancels out. Alright, let's look at something else here. If I had 3a minus a, we have to again remember, and I'm going over and over the same thing so that you remember that we have that imaginary friend of the variable, number 1. So even though I just had this variable here, no coefficient, I know I have that invisible or imaginary 1 coefficient. So at this point, just think in terms of our coefficient. What's 3 minus 1? We know that's 2. 2 what? 2a. Let's prove it. A plus A plus A. Subtract 1a here. So that cancels that out, right? I took away 1. How many do I have left? 2 a's. So there you go. 2a. And then when we look at this with our model, we also have 2a. So that's an A also, not a 9. So that's how we can work with our variables in subtraction. It's the same thing, just think of the regular coefficient in front of it. Just think of the coefficient. Don't get concerned about the A. Just think about the coefficient and break it down to a simple math problem, and then you can work with it. Let's look at something with 3 terms here. 8y minus 3y minus 5y. Alright, now regardless of the number of terms we have, we have to think of PEMDAS. Do I have parentheses? No. Do I have exponents? No. Multiplication? Well, there is this multiplication between the x, the coefficient and the variable, but we don't know what y equals, so I'm going to say no. No division. Do we have addition and subtraction? Well, we do have subtraction. I have subtraction here. So when I have that, I can just go left to right. If it's all addition or subtraction, just move from left to right. Start at the beginning and go this way. It doesn't matter whether the subtraction comes first or the addition. Just move left to right. So at this point, let's go 8y minus, start out right here, 8y minus 3y. Well, right away, I know that that's 8 minus 3, which equals 5. Don't forget to bring down your y, 5 y's. Now I have 5, so I took care of this. 5y minus 5y. Well, here's 5 y's. And I'm subtracting 5 y's. Well, that cancels out each one of these. How many y's do I have left? 0. No y's left. So you see, regardless of how many terms I have, you just go step by step by step. I took the first 2, worked with it right here, broke it down step by step by step. I spoke about this earlier. Just go step by step by step. Very simple. Just make it a puzzle. The fun thing about algebra, it's just a puzzle. And we love doing puzzles. So just, okay, puzzle, puzzle, puzzle. Just jigsaw it down till you get it at its most simplest form. And then combine your like terms. So you're simplifying, simplifying, combining till you actually get to where you have it at its most simplest form. Alright, what if I had addition and subtraction in here both at the same time? Let's look at that. So if I have 2x plus 3x minus 4x. Alright, again, I'm not solving for x. So I don't have to isolate the x. All I'm doing is simplifying. I'm just making it simpler. So make it simple. That's all I'm doing right now. I'm not solving for anything. I'm not solving for x. No. I'm just making it simple. I'm going to make it simple how? Combine like terms. There we go. So let's look at this. What can we combine? What's alike in this problem? They all have an x. Woo-woo! So that means all 3 of them are going to be combined. Looking at PEMDAS, I see that I have addition and subtraction. So I'm going to just move left to right with my problem, like this. So first things first, I'll take my first 2 terms and see what I come up with. I'm going to take these 2 terms. So I have 2x plus 3x. 2 plus 3 is 5. 5 what? 5 x's. How do I know that? X plus x, x plus x plus x. How many x's? 1, 2, 3, 4, 5. 5 x's. Yep, double check correct. Double check correct. Alright, now go back over to the original expression. What do we have here? We have a minus 4x or a negative 4x. So I can rewrite it here. Put the 4x down here. I'm just bringing it down here. So I did a rewrite. Now, can I combine them? Sure I can. They both have an x, so they're like terms because the variable is the same. Yes, they're like terms. So 5 minus 4. That equals 1. 1 what? 1x. Let's prove it. 5. X is here. And 4 negative x is here. Or 4 subtractions of an x. So I cancel out. This negative x cancels out that one. This negative x cancels out the positive. Another negative x cancels out another positive. This negative x or minus x cancels out this positive or plus x. What do we have left? We have 1x left. Does that check out with what we got? Yes, it does. We have 1x left. There you go.